Yo, what's up guys? Welcome back to another video. Today I'm highlighting an issue and I kind of want to address this in its own video because I think it deserves it. I've come into a real world example here in my project. If you are following the Code With Me series, this is the RSG project. This is one of the projects I'm working on along with two other ones, Curio, which is my social media platform that I'm kind of working on. And the Task Ripper library is my pilot episode for the Code With Me series. So if you're interested, check out the links below. And without further ado, let's get started. So one of the issues that I'm trying to solve is I have a frequency unit. So a frequency unit is a class. You give it a unit, a number, a big integer is just a large number, which is the iterations per second. And then we have a function, iterations per unit. So the idea of the frequency unit is to encapsulate how many iterations per second were you to generate a unit of something. So for example, all right, so in my old random string generator program, we were able to brute force strings like this. And I wanted a way to display statistics on how long it would take your computer to iterate, for a various amount of time. So here's per minute. I do 392 million iterations per minute, 23 billion per hour. Anyways, how do I generalize that? Well, I came up with describing, instead of, per minute, per, hour, you just tell me what the unit is, and then you tell me how to compute it by giving me a function. All right, so far so good. Here are the functions, iterations per minute, iterations per hour. And I'm kind of showing you how we calculate that. We take the seconds for minute, for example, and we multiply it by 60. And that gives us the amount of iterations per minute, the number. We're returning the big integer. All right. Here's per hour. We have a new big integer and we multiply 60 by 60. All right, so I want to keep adding to this list. I don't want just four, things. I don't want minute, hour, day, year. I want decade, I want, century, and I want millennia, at least. So we're going to keep going. And in order to write these functions, to save time, I'm copy pasting. Might be ringing a bell if, if you're copy pasting code. It sounds like a bad thing, and we'll talk about that in a second. But this is the iterations per day. Now it sounds like, whoa, I just did that so quick. Yeah, I wrote that code quick because it's in the moment. I'm in my own thoughts. I know what I'm doing, and I believe this to be correct. Now, let's talk about the issues with doing it this way. I solved the problem. I want to write a function that returns a big integer that tells me the iterations per minute, given an iterations per second parameter. This is all correct. But when I come back the next day or another developer takes a look at this code sometime later in the future, well, it's a little hard to maintain because let's say I made a mistake in one of these because I didn't write unit tests. Let's say instead of 60, I accidentally pasted 59, or better yet 600, because that's easy to catch, an extra zero. So I see 60 in there, but maybe I didn't see the zero. And let's say while I'm copy pasting this function, let's say to write the per day function. So I changed the name to per day, but I copied over the wrong code. But I added 24, so it looks right, syntactically this all works, this will all compile. But when I go to actually run the code and actually use this code, I'm expecting much shorter numbers, but I'm getting much larger numbers. It might lead me to dig into code if I ever figure out this is a problem. This may go unnoticed for a long time. But the point is, I've been copy pasting code, which is kind of telling me, why are you copy pasting code? Can I do this a better way? And the answer is yes. Now, instead of copying the code, which you think is really simple, until you notice that you could potentially be copying a mistake over and over. Now, when I come to fix this, I'm not just changing this line on line 27 here. I'm changing line 30 and so on, all the functions I wrote. And those all have to be tested once again. And let alone, you know, it being wrong, you know, copy pasting. It's so hard to read. Let me show you now, like 10 seconds later, or, you know, a couple minutes later after I wrote the functions, how hard it is to actually reason about this code. All right, iterations per minute. How do we calculate that? We multiply a big integer. We have iterations per second times 60. Okay, I got that. I read that, you know, first try, easy, no problem. Now here's the second one, iterations per hour. Okay, iterations per second, okay, and we times 60. Okay, this part is the minutes, and we multiply by 60. Okay, that's the hour, I think, right? Okay, a little doubt, but anyways, nonetheless, we go on. We got it. Now the iterations per day. This is a much larger unit than hour. A day. But we're still working with iterations per second. So how many seconds are in a day? I'm already confused. Okay, well, we multiply that by 60. Wait, why is there a 60 here? What does that have to do with the day? You know, I usually think of day in terms of the previous unit, like hours, 24. Well, that's all the way over here, but we're multiplying two other 60s. Anyways, you might be wondering, you know, okay, you can look to the function above to kind of see what the 60 times 60 is all about. But that's the problem. The fact that I'm looking at the other function to see what it's doing is the problem. It doesn't read well. So I actually have to look at what the hours is doing, how it's calculating. How do we fix a problem like this? Well, let's fix the hour, and we can do that by actually reusing the function. So let's call iterations per minute to calculate this. So in order to calculate the iterations per hour, we're going to calculate the iterations per minute by passing it in. You know, we have the iterations per second here. We pass that bad boy in, and we're going to multiply, well, by 60 only. So it's kind of matching iterations per minute right now. But it reads much better because in order to calculate the iterations per hour, it's the iterations per minute times 60. That reads so much better. And watch this, it gets better. Instead of this times, you know, we could do iterations per hour times 24. But before I do that, there's actually a real problem here that will go unnoticed if I keep doing this. So for example, if I did per year now, if we take a look closely at the big integer, this constructor is taking an integer. We're at 315 million. All right, now watch as I keep going, what's gonna happen. All right, so iterations per century is another times 10. And then if we keep going, here we go. Check that out. It even tells me my idea. This operation overflows at compile time. So if you don't have that feature on your IDE, or, you know, I think I'm using a code analyzer that's doing this. Well, this is actually a problem. This is going to underflow. I'm going to pass an underflow integer into the big integer, and I'm going to get a negative number for this because it's going to overflow, or it's just going to throw an exception. I don't know exactly the behavior here, if I do it in check mode or not, but either way, this is a problem. We could avoid it completely by actually doing the method that reads better. So if I do, in order to calculate the per day, we're going to do iterations per hour multiplied by 24. I'm familiar with that unit because, well, I associate days, like anything revolving around days, I associate it with months, the next unit above, or the previous unit, which is hour. I don't associate days with minutes, you know. Today is about 300, or, you know, I was up for about 2,000 minutes today. Like, no one says that. You say hours. I was up for 8 hours today, or 10 hours today, whatever. So my point is, this reads better. It actually saves on code. So let's say I made a mistake somewhere. In order to fix it, I just need to update that function that's broken, because since it's calling other functions, as long as the other functions are right, I could guarantee that the rest are right. So again, new big integer, and the only unit here is 365. And we won't get this overflow issue because at most I'm really passing in one parameter. So anyways, that's about it, guys. I think I demonstrated the point here. Let me know if you guys have any questions about it, and I'm happy to talk about this. But anyways, this is a way you could clean up your code with a real life example, and my god, it reads so much better and much easier to maintain for anyone in the future. Thank you so much for watching. Peace out now.